This video goes over the first three examples on the example problems with the net force. Bonnie's going to help. First, we'll summarize some of the concepts here at the top of the paper. When all forces are not balanced, there is a net force. And net forces cause acceleration. We talked about 5 different kinds of forces that we can put on the force diagram: tension, applied force, friction force, weight, and normal force. There are other kinds of forces. We're just not going to include them yet as we're doing the introduction. The equations we can use is the friction equation. Friction is equal to the coefficient of friction times the normal force, how much those surfaces are pressed together. We have Newton's second law, F equals ma, that we can use 2 different ways. If you use weight for the force, which is pull of gravity, for the acceleration you use 9.8, which is acceleration due to gravity. Or, remember, net forces cause acceleration. If you use, for the F, you use net force, then the A is the acceleration of the object. So the equations we can use in Chapter 4 is the friction equation, F equals ma, and any equations that you determined from the diagram that you've made. Example 1. We're going to use the same structure whenever we approach and solve these problems. It's different than probably any book, and any other teacher does it. It's kind of my thing, and it works when you're first starting. Now, you won't always solve problems like this. You won't always write all this out. But when you're first learning, this is a good structure for learning how to solve these. First step is to underline all the numbers and identify what they are. It says, what is the acceleration? Acceleration is what we're looking for. 34.8 kilograms. Kilograms measures mass. 284 newtons. We have a lot of kind of forces. They're all measured in newtons, so you need to read more closely. An object pushed with a force of 284. So 284 is the applied force. And then it tells you the coefficient of friction. But I still like to write that on top because then it all stands out. It's all right here in bright pink. I can tell what I know. The next step is to draw our diagram, because that's where our equations come from. This thing's accelerating, so I know I need a net force when I'm done with my drawing. Somebody's pushing it, and I know there's a friction force because there's a coefficient of friction. A lot of times they'll say you have a frictionless surface, so just because you're pushing an object and accelerating it doesn't necessarily mean there's friction, but the fact that there's a coefficient of friction tells me there is. Okay, so I know I have got weight down. Every problem on Earth is going to have that. Assume it's sitting on a table or ground or something that's supporting it up. The box pushes on the table pushes on the box, according to Newton's third law. And we're drawing all the forces on the box. So here's the table pushing on it. The supporting force of the table, the normal force. Somebody's pushing it to the side. I pretty much always draw it going to the right. So if the applied force is that way, and friction opposes the motion. And I drew that smaller because I need a net force. There's acceleration. So they don't balance out like they did in yesterday's examples. I'm going to have a net force. So now I write equations for my diagram. In this problem, not always, but in this problem, the normal force equals the weight. And the applied force minus the friction force equals the net force, the force that doesn't cancel out. Okay, so there's nothing too different yet, but this is what's different, my kind of setup here. I like to make a plan. I say make a plan and follow it. So you make your plan by knowing where you need to end. I will be done with this problem when I find acceleration. So way over here at the end, that's going to be my last step of this problem. I'm going to find acceleration. Now I just need to think about how can I do that? How can I find, what equation could I use to find the acceleration of the object? Well, we only have one equation that has the acceleration of the object in it, and that's going to be F equals ma, when the F is the net force. Now I'm not going to plug anything in there and try to solve it yet. I'm going to make my plan. So I'm looking at this. Do I know the net force? Here is what I know. No, I don't know the net force. So before I get to this equation, I'm going to have to somehow find the net force. So that has to be a step before that. Before I move on, I want to make sure this equation is good, because I don't want to get to the end and not have what I need. So I need the net force. I'm going to find it here somehow. I need the mass. Do I know the mass? Yeah, I do know the mass. And then I'll be able to solve and get the acceleration. Okay, so this is good. So now we back up to this step. How can I find the net force? I can't use this equation because I'm using that one to find acceleration. I'm not going to be able to solve one equation for two variables. So I need a different equation that has a net force in it. This one from our diagram. So that's the equation I'm going to use to find my net force. Okay, let's see if we're ready for this equation. Do we know the applied force? Yeah. Do we know the friction force? No, we don't know the friction force. So before we get here, somehow, we're going to have to find the friction force. I'm not plugging any numbers in yet. I'm just making my plan. So I know applied. I'm going to find friction somehow, and then I'll be able to solve for net force. So this is good. Now I'm backing up. How can I find the friction force? I'm going to use the friction force equation. Friction equals coefficient of friction times the normal. I'm looking for friction force. Do I know mu? Yep. Do I know the normal force? No, we don't know the normal force. So really I'm kind of using this equation in this problem, not always, but in this problem, the normal force equals the weight. Do I know weight? No, but I can find weight. I'm going to write myself a note over here so I remember that the normal force is equal to the weight. And I'm going to find weight. What equation can I use to find weight? I can use F equals ma. Remember, here I used it was the net force and the acceleration of the object. I'm going to use it the other way, where it's weight and 9.8. So the force will be weight. That's what I'm looking for. Do I know the mass? Yep. Do I know the acceleration? Yes, because it's acceleration due to gravity, 9.8. So I'm ready. Once you backed up to a point where you can start, you know everything, start and go forward. Or I say make a plan and follow it. So why don't you pause the video and try it yourself right now before you hit play. So you can see how this works. You usually need your last answer for your next problem. We found weight and we used it for normal force. Now we found friction because we needed it in this equation. Forces are measured in newtons, of course. Make sure you're using your equation. So here I'm subtracting. Do not just write on a paper. Make sure you have your brain engaged here and you know where every number came from in this problem. I usually round every step to 3 sig figs, but then it'll be a difference whether you cleared out your calculator and put it back in, or whether you used what was in your calculator to go to the next step. So we might get off a little bit along the way. Usually if you're within a couple of this last digit, that's why we keep 3 sig figs, and if that third sig fig you're within, 3 or so, you're probably good. Next example. Follow our structure. Underlining, we're looking for acceleration again. We will not always be looking for acceleration, but we are in this example. Read the problem yourself, pause, and see if you can identify the numbers. 45 Newton object, that's the weight of the object. Pushed with a force of 18, that's an applied force. And then, again, we're given mu. Make a diagram. So again, somebody's pushing on an object, there is friction, and it is accelerating, so I know it in a net force. Turns out it's the same as example 1, the same diagram. We've got weight down, we've got normal force up, we got an applied force to the side, and friction opposes a motion, and it's smaller. So I'm writing my equations from the diagram. Normal force equals weight, applied force minus the friction force equals the net force. Remember, the net force is the force that doesn't cancel out. Ready to make a plan. Our last step will be finding the acceleration. We will be done with this problem when we find acceleration. The acceleration of the object, so we'll use F equals ma, where the F will be the net force. Do we know the net force? No. So before we get here, we will have to find the net force. Do we know the mass? No. We have to find the mass before we get here. Make sure this equation is completely good before you back up and start writing equations. Otherwise, you get to the end and you don't have everything you need. So also before I get here, I have to find the mass of the object because it's not one of the things I know. And here's where I screwed it up when I was doing the screenshot part on the board, writing in my classroom. Next, I should come here and write m on the line to make sure that equation's good, and then come and write this. In the screenshot, I write that next, though. So net force, how are we going to find net force? We already used this equation, so we're going to use this equation from the diagram. And then before we back up there, we should look at this and see if we have everything we need. Do we know the applied force? Yes. Do we know the friction force? No. So before we get here, we're going to have to find the friction force. I should write friction force here right now. And then I'll be able to find the net force. Coming back to here, what equation will I use to find the mass of the object? Well, the only equation that has an m in it is F equals ma. We used it here where it was the net force and the acceleration of the object. We can use it again where it's going to be weight and 9.8. We know the weight. So that equation will be good. I back up to here. How do I find the mass of the object? The only equation that has an m in it is F equals ma. So here I used it, and it was the net force causing the object to accelerate. Here I can use it where it's weight, 9.8. I'll write myself a note to remember that's weight. Okay. Do I know weight? Yeah. I'm looking for mass. Do I know A? Remember, this is the pull of gravity, so this is acceleration due to gravity. And yeah, I know that, 9.8. So we're ready to back up here. Friction force. I'll use the friction equation. This equation has friction force in it, but I'm already using that to find net force. So I'm going to use the friction equation. So I'm trying to find friction. Do I know mu? Yeah. Do I know the normal force? Well, in this problem, the normal force is the same as the weight. So yeah, I do know it. All right, I know everything. Ready to go forward. So start at the beginning and follow your plan. Again, stop the video and do it yourself. And then play and see if you got it right. And correct your answers. That should be 13.0. Later I come back and correct it, but that should be 13.0 newtons. So there I divide both sides by 9.8. So here I just subtract. I know I'm getting fickle about my sig figs here. Divide both sides by 4.59. And I get the acceleration as 1.09 meters per second squared. So again, if we differ by this last digit, you're fine if you have the right process. One more example in this video. Example 3. Start by underlining. Looking for acceleration again. We will not always be looking for acceleration. But in example 3 we are. Kilograms measures mass. It has a lift force of 9250. That would be considered an applied force. Applied force is kind of the catch-all. If it's not, if it's not a rope, if it's not, rubbing surfaces, if it's not the pull of gravity, applied force is what we call a lot of those. Just other things. So in this case, it's a lift force by the engine. You can think of the engine as lifting the helicopter. There's acceleration, so I know I need a net force in my diagram. So it's accelerating down, so I need a net force down. What forces are on my diagram? Got weight. Weight's down. Do I have a normal force in this problem? No, it's not sitting on the ground. There's no supporting surface. Do I have a tension? No. No strings, no ropes. Do I have friction? No, because in this course so far, we're going to ignore air resistance. Air resistance is a form of friction, but we're only going to consider friction from surfaces rubbing against each other. So no friction. All I have is this applied force. And it's a lift force that is up. And I know I need a net force down, so my lift force, my applied force, must be smaller. And that's it for this problem. So weight minus the applied force is the net force. Notice I'm starting to wean you here. I didn't write anything. On the back, you even have to draw your own box. So I will be done with this problem when I find acceleration. I don't usually write find. So what equation will I use to find the acceleration of the helicopter? Net force is called acceleration. So it's F equals ma, where this F will be the net force. Do we know the net force? No, so we'll have to find it. Before I back up, let's make sure this is good. I'm going to find the net force. Do I know the mass? Yeah. Then I'll be able to solve for the acceleration. So that is good. So now I'm backing up to here. How can I find the net force? I'll use the equation from the diagram. Do I know the weight? No. So before I get to this, I'm going to have to find the weight. Do I know the applied force? Yes. And I'll be solving for net force. So this will be okay when I get there. How will I find weight? I know the mass, so I can find the weight. Weight, 9.8. I'll use F equals ma. Remember, that's the equation to go between mass and weight, or weight to mass. So I'm looking for the force, which is weight. I know the mass, and I know this will be acceleration due to gravity, 9.8. I know everything. Ready to go forward. So this is just a three-stepper. So we made a plan, now follow it. Pause it and try it yourself, and then play. I know I'm not being very consistent with my sig figs here. Here I have 4. But as long as you're getting the process, I'm okay with it. Divide both sides of the equation by 985, and I get the acceleration of the helicopter is 0.409 meters per second. That's all for this video. The next one will have the other 3 examples.